Now we're going to talk a little bit about glass cutting. I'm going to talk for just a moment. There's some theory behind this. There are a few variables that you need to consider when selecting the right cutting system for your application. So different glass thicknesses, different glass types, all might require a different configuration of your cutting wheel. And there are 4 variables that go into your cutting system. There's angle, speed, diameter, force. It's really easy to remember if you have ever taken a typing class or you look at your keyboard where you hold your hands, A, S, D, F. That's a real easy way to remember it. So different thicknesses may require a different wheel angle. Speed equals force. Faster you go, the less force you need. Diameter, a large diameter wheel is going to bite into the glass a lot less than a small diameter wheel. So there's reasons for using a large wheel. A large wheel will last longer before you have to change it, but a small wheel might be better if you're doing tight arcs, radiuses or shapes. And then force. You want to use as little force as possible, with the intent of we want to achieve a fissure depth, meaning that wheel, we want to penetrate into the glass surface about 10% of that glass thickness. So you can see here the effect of the different angles. The principal stresses of a cutting wheel radiate perpendicular to the sidewall of that angle. So you see where the 120 and the 155, so the more sharp your angle is, the more that the principal stresses and forces radiate straight outward nearer to the surface of the glass. Whereas a 155 and a 165, they promote a deeper fissure or a deeper, it imparts stress deeper into the glass, if that makes any sense. And we're going to demonstrate that, the effect and what that means. So again, like I mentioned, you can use your jeweler's loop. These are some images that I took just of scoring some 4mm glass on the left here. And I've got a 0.4 fissure depth and a 4mm glass thickness. So that's about 10%. So you want to you can evaluate this with your jeweler's loop or USB magnifier or some other tool. But that's kind of the guideline. So if you're going to push down really hard, you're going to get a really deep fissure depth, but your edge quality, it's going to be jagged with shark's teeth and hackle and issues. So let's talk about this. So sleeves, gloves, safety glasses. The proper way to score glass is you're going to have your piece of felt or carpet and your 8-inch square piece of glass. You're going to keep the tool at about a 45 to 60 degree angle from vertical. Pull it towards you. Never start off the glass. You want to start a 1/16 of an inch or a millimeter to 2 millimeters on the glass. You never want to run from the top onto the glass. You want to start on the glass, but you want to run the cutting tool off the glass. You don't want to stop short. Okay? Pull the tool towards you, use consistent force, use a consistent rate, and make sure that you don't dip it left or right as you're cutting. Reason being is that sharp angle, how it imparts the stress. If I put my tool at an angle, what it's going to do is it's going to have high surface stresses on the one side and low surface stresses on the other side. So you're going to get an inconsistent score line. Okay. So now braking. You want to take your fingers, curl them up underneath the score line. You could see the score line there going horizontally. And then using your fingertips as a fulcrum, put your thumbs on top, put that score line in tension. And the idea is to get the score line to run from your fingers to the other side. So we don't want to put the edge right on the edge and try and break it off on the edge of the table. We want to get that score line to run from where you are to the furthest away. Okay. So now, and this is how we would evaluate the edge quality. We want to see that we get about a 10% fissure depth or penetration depth of the cutting wheel. And we want to look at the edge quality. If there is jagged pieces, bits below the fissure line, shark's teeth, or any wavy lines underneath, such as these, we're talking bad. So what I'd like you to do is take the, let's start with the 135 tool and make a few scores, and you're going to hear. So start on, I don't know if you can hear that. Ooh, this is really interesting. I'm getting, and it's hard to see here, I'm getting a lot of slivers. It's actually popping. So I've done one of two things. I've either got too strong or too sharp of an angle, or I was pushing down too hard. So I'm going to try pushing a little less. Much better. But it's still blooming a little bit. It's still chalky a little bit. Why don't I try the 127, which is a little bit sharper. Wow, that one really, really is creating, it's incredibly difficult to see, but there is all kinds of,
A lot of flakes.
there's all kinds of flakes, and it's snapping and popping. Basically, that sharp angle is directing all that force straight outward, and it's causing the glass is not strong enough at the surface, and it's causing all of these slivers. Let me try a 145. That looks really nice. It's the least chalky of them.
Oh, yeah.
Now let's try the 155, the really blunt tool. Ooh, I can't hardly get that into the glass. I don't know if you can hear that.
Yeah.
It's really kind of quiet, almost like I don't hear any scratching sound at all. So can you feel a distinct difference between the 127, 135, 145, and 155?
Yes.
Big, huge difference. Mind you, we're working on 4mm glass, and it might behave a little different on other glasses. So now that you've kind of got the lay of the land on that, get a fresh piece of glass and make a score line with a 127, maybe make it an inch or inch and a half from the edge of the glass. Wow. I've got glass slivers going all over my keyboard. It's going to be fun later. Now let's take the about another inch and a half away from that. Use the 145 and make a score line. And then another inch and a half from that, take the 155. I have to press really hard with the 155. Remember how I said you want to use as little force as possible?
Yeah.
That's telling me that 155 is probably not good for this glass, but maybe. So now I'd like you to curl your fingers around and try and break the 127. Okay, I could break it.
No, it's not breaking.
And then set it down and go to the next one and break the 145. Wow, that broke a lot easier. And now go to the 155.
Spin it around.
That broke okay. And from this point, you can start to evaluate the cause and effect of more or less force, different angles, and the relative ease with which that score line breaks out, okay? You can also use your jeweler's loupe or magnifying glass, and you could take a look. Below the fissure line, I see a lot of shark's teeth on my 127, which is the upper left bad score. Okay, I'm gonna look at that looks pretty good. 145 looks really good. 155 doesn't look too bad either, but I think I'd choose the 145 degree wheel for this particular glass thickness. Now, when you get into different glass thicknesses, like I said, the more blunt the angle is, the more it's going to drive that fissure deeper. So maybe thicker glasses than 4 millimeter might need a more blunt angle. Maybe it needs a 155 if you're running 6 mil, 8 mil glass, and you need to get that fissure depth to the right depth. Right. You want to look for slivers, look for chalking. You use your ears just as well as your eyes on this. And if it sounds scratchy, more or less than another one, maybe you want to keep that in mind, and that's going to really result in not as good of an edge quality. So shark's teeth, all of these defects in the edge are possible stress concentrations for a thermal expansion, thermal contraction. If you hit a glazing bead into your IG, it could stress the glass, and that could be an initiation point for a runner. Most glass breakage in the field, except if it's like a baseball going through the glass, initiates from the edge, from out of the sight of vision, inside the glazing pocket. So very possibly there is a stress concentration and a initiation point for that glass to run. So you want to be real careful that just because you made a good IG, what you think is a good IG, when that gets subject to higher and lower temperatures, it could be subject to a cracking condition or a runner. So it's really hard, really hard to control all of these variables by hand. I don't recommend making production IG by hand. You can have a semi-automatic easel table, but really the way to control good glass cutting consistency and quality is through some sort of glass cutting machinery or automation system. Okay, so I hope this was valuable, helpful, informative, and I thank you much for your time.